Hello and welcome to the EPRI Current. I'm your host for today's episode, Samantha Gilman, and we are joined by a powerhouse panel to talk about EPRI's 2025 Quantum Challenge Fusion Edition. I'm going to quickly introduce our guests and then let them tell you a little bit about what they do at EPRI, and then we'll dive in, we'll learn a little bit more about fusion, we'll learn about nuclear innovation, and we'll hear more about this quantum challenge and how you can get involved. So quickly, let me introduce Diana Grandas, Lead Fusion Energy Research Analyst at EPRI, Emma Wong, Lead of Nuclear Innovation, and Dr. Charlyne Smith, Nuclear Engineer in EPRI's Nuclear Innovation Group. Ladies, hello and welcome. Diana, why don't you quickly tell us what you do at EPRI?
Thanks, Samantha. Hi, everyone. I'm Diana Grandas. I am a Fusion Energy Research Analyst here at EPRI. My work primarily is to support our Fusion Energy Strategic Program, which has a goal to support and enable a portfolio of research to support commercialization of fusion.
Wonderful. And did I see that you just completed your master's? Congratulations.
I did. We're about a month out, so I have a little bit of a life now, and I have my weekends back and evenings.
Whole new
back,
world.
so, yeah.
Congratulations. Emma, why don't you tell us a bit about what you do as the lead of nuclear innovation at EPRI?
Sure, Samantha. Well, my day job really is looking at the disruptive innovations around the world, looking at it globally and where we can actually partner, collaborate, and coordinate these types of things, not just for the nuclear sector, but all of energy. So that's why we're really working with Diana here, because this is looking at all of energy and what we can do to really push this forward.
Great. And last but not least, Dr. Charlyne Smith, tell us a bit about what you do.
Hi, thanks, Samantha. I'm Dr. Charlyne Smith. I'm a nuclear engineer, primarily supporting nuclear technology and innovation with Emma. So she very nicely and concisely summarized what we do in that program. But I also, at the same time, support the fusion group, which is currently what Diana's portfolio is comprised of.
Wonderful. So let's level set for our listeners and give them a little background information before we jump into this challenge. Diana, can you tell us what is fusion?
Yeah. So fusion is the process by which two lighter nuclei combine or fuse together. And this process generates a large amount of energy. And it's being proposed as a potentially game-changing energy resource. It has potential to be a scalable, non-emitting, firm resource and option for the future grid. I will say that fusion is not easy. It requires some very specific conditions to happen. So to make fusion happen, you have what's called a fusion fuel, typically some sort of hydrogen isotope. You heat it up until the electrons are stripped from the nuclei. That's called a plasma. And once you have that plasma, you still have to get it to the right conditions to enable fusion to overcome that electrostatic repulsion of the charged nuclei. So the plasma needs to be held at the right temperature, it has to have the right density, and be held at those conditions for a long enough time. And once those conditions are satisfied, the nuclei combine and fuse. And when that reaction happens, there's actually a slight change in mass between the reactants and the final end product. And per Einstein's equation, E equals mc squared, with a small change in mass, you have a large release in energy. So that's where we get the idea of having a potentially very abundant energy resource through fusion. And fusion is actually what powers the sun and stars today. So fusion's happening. It's just on timescales of the universe right now. And the challenge is, in the sun and stars, you have these large gravitational forces creating those high heats and high densities. Here on Earth, we don't have the sun. So we have to create basically a sun in a bottle and replicate certain conditions. So researchers are using magnets, lasers, using electric fields to not create the exact same process as the sun, but similar conditions so that fusion can be achieved on Earth.
Wow. So Emma, now to the other side, can you give our listeners a foundation of what quantum computing is?
Well, I'm not going to go into as much detail as Diana. Diana is much smarter than me in all of these different areas, and she probably actually could give you a really good answer. about what quantum computing is. But for the listeners today, this is what I really want you to take away from quantum computing. What you need to know, it's a type of computing that uses the principles of quantum mechanics. And it's really, really complicated. And I went to grad school and I looked at all this, and I probably still can't really explain to you exactly how this happens. That's why physicists actually go and get PhDs in this field. But what you need to know, it uses the properties of quantum mechanics to solve problems. It is actually used to try to make computers. And when you actually create a quantum computer, it's meant to do that processing faster. And so that's really what it's trying to do, is take complex problems that really cannot be solved by a classical computer, because it's just will take probably on the time scales that Diana was talking about to actually solve that problem, and actually do it in time scales in our lifetimes. So something that could take a few years to solve, and this is really not acceptable, maybe could take, a month, or maybe even hours, depending on how big of a quantum computer that is. The other thing that's really interesting about quantum computing that you need to maybe know and look up yourself is there are two quantum phenomena that are really quite interesting that you might want to look up in your own time, called superposition and entanglement. And so that's really the process of quantum mechanics that really drives this field forward.
I just want to jump in there really quick just to kind of maybe break down superposition and entanglement just a little bit more. So, I mean, when you talk about quantum mechanics, quantum fundamentally, as Emma said, is governed by basic principles of that govern essentially how the smallest particles in the universe operate. So unlike classical physics, where you can actually say that you're in a specific state of matter, where whether you're a solid, liquid, or gas, in quantum mechanics, you use that to describe how particles can be or can exist in multiple states all at once, which is basically superposition, right? And in addition to that, these particles in different states all at once, they can influence each other over various distances. And then they also change when they're observed. So just to kind of break down exactly those primary principles of superposition and entanglement that govern quantum.
Well, this is certainly not an easy concept to understand, either of these. And I'm glad that our listeners have you to help us understand a bit about what they are. So getting back to you, Charlyne, tell us a bit about why fusion was selected for this year's EPRI's Quantum Challenge, and also tell us a little bit about what the challenge actually is.
Sure, absolutely. Fusion was selected to be EPRI's Quantum Challenge edition for this year because, as we've seen, there's an increasing demand for 24/7, potentially abundant clean energy, and it seems that fusion could potentially fit the bill on that, with the again, increasing demand from various industries. I mean, primarily data centers are a hot topic at the moment. And if we can really advance fusion to the point where we have this potentially abundant, clean source of energy, then it seems that maybe our problems will all disappear. And so I think EPRI recognizes that technology innovation advances when industries intersect, ultimately. And I think what EPRI really wants to do is see how we can intersect quantum and energy to be able to advance or accelerate advancements in fusion in particular. And so in doing that, we can try to leverage quantum to be able to in doing that, we can try to leverage quantum solutions to address some of the challenges that we have in fusion energy, in particular materials and controlling the plasma.
So when you say it's a quantum challenge, what exactly does that mean?
When we say it's a quantum challenge, we're saying how can we apply those fundamental principles that Emma and I described earlier about being able to manipulate or control or monitor these complex atoms and particles that are interacting in a plasma to be able to have real-time monitoring to control the plasma itself, to be able to simulate any disturbances in the plasma that can lead to any energy reduction or changes in the system. And in addition to that, from a materials standpoint, try to figure out how these complex interactions of these particles can influence the behavior of materials, and in doing so, help to design high-performance materials that can withstand those extreme environments.
Sounds like quite a challenge.
So,
Back over to you, Diana. You were starting to allude to this and talking about this earlier, but what steps is EPRI taking to simultaneously support the current R&D community when it comes to fusion, to bring this technology up to the maturity needed for real use, while also addressing the challenges on the path to commercialization?
Yeah, and this certainly goes in with the question of why are we doing this quantum challenge for fusion in the first place. So back at the beginning of 2023, EPRI launched our Fusion Energy Strategic Program, again with the goal to support and enable fusion commercialization. And this was creating that program was prompted by the large amount of activity going on both in the public sector research domain, but also the private sector. There's been billions of dollars raised specifically for fusion energy development. And all that activity, both funding-wise, but also technical milestones you've been hearing in the last few years, the real indication towards the industry moving towards real commercial systems. So EPRI's role here, EPRI is here to support end users of energy as well as the public. So in addition to the research that EPRI does day to day to make sure that the lights stay on, supporting all types of existing energy technologies, we're also here to make sure that our members and the public are ready for whatever's coming around the corner. And with that activity in the fusion industry, we wanted to make sure that fusion was on the table, that we're looking into it, making sure that our members are aware of the technology, so that they are ready for it when it's technologically mature and ready for adoption and commercialization.
So given that, what are the areas that EPRI is looking at to address these challenges for commercialization in the R&D space?
Yeah, so again, two main buckets. One, again, preparing end users of fusion. So that's making sure that they're aware of the technology, briefing them, making sure that they are aware and connected to all of the technology developers out there in the private sector. And then also doing R&D to support questions relating to deployment and energy system integration. While we are preparing our members and future end users of fusion, there's of course a need for the technology itself to be ready and viable and compelling enough for adoption. So we are actively engaging with the fusion research and development community, both in the public and private sector, to understand needs and develop a portfolio of R&D efforts to support development of fusion energy in the nearer term. So topics like materials development, testing, qualification of said materials, understanding needs for a fusion fuel cycle and operating experience are just a few of the topics that we're looking at to support development in the near term.
And to that point, I'll say that EPRI has a materials lab that we do some of this work at out of our office in Charlotte.
The fusion program, staff-wise, is small, but we are already leveraging a lot of the expertise and staff and know-how across EPRI. Even if folks haven't looked at fusion specifically, there's a ton of expertise that we are leveraging already to accomplish some of our goals.
That's right. There's no lack of experts at EPRI. It makes getting folks for this podcast real easy. So, and you three are on that list for sure. I want to get back to the challenge a little bit to share with our listeners about how to get involved, where do they apply, when the applications close. So, Dr. Charlyne, can you tell us how people can submit proposals, where do they go, and when are they due?
Awesome. Of course, Samantha. Before I answer that, though, I know people can hear the term fusion energy, and quantum and get maybe a bit overwhelmed, I just want to say that this challenge that EPRI has is creating a space for conceptual ideas. So really, we want participants of this challenge to think up the most disruptive ideas, even if it may not be anything. You may do a literature review and see that nobody's really looking at an idea that you have. We want the most disruptive, the most interesting, conceptual. Again, they're conceptual ideas of how we can apply the principles of quantum technologies to address specific fusion energy challenges. In this case, with this challenge, we're talking about how can we design high performance materials to resist or to be resilient in extreme environments, in particular fusion, and also how can we apply these same quantum principles to effectively monitor, control, and stabilize the fusion plasma, because those are two of the primary problems that we have to address in the fusion community. So with that, the application, the challenge is open to everyone. When I say everyone, I mean everyone. So whether you're an individual, whether you're a student at any level, doesn't matter, whether you are with a company, research organization, government institution, everybody. So if you have an idea, and if you can find some background information to support your idea, where you can, create a guideline to what you envision how you envision your idea or your proposal addressing any of those two challenges. That's really what we're looking for, because what we'll do then is to be able to perform a technical review to figure out what ideas could be prioritized and advanced so that we can try to address these challenges that we've identified.
So is there a winner or a group of winners? What happens when your technical team looks at these and says, yes, this could work? What happens at that point?
Yeah, for sure. So whether you apply as an individual, with a company, as a student, individual student, or even student group, whatever, you're competing for the opportunity to win cash prizes. I mean, money in your hand.
To do the research, correct? Money to do the project.
Well, no, not even. These are cash prizes that we essentially, award to people who have the most disruptive ideas, the most interesting proposals. We're essentially giving you prize money for how out of the box can you think, essentially, is what it is.
Get people thinking, get those ideas going.
Exactly. Get your creative juices flowing. We're essentially giving you prizes to think outside of the box. No strings attached. Maybe with the exception that if you do win and we select your application, that you would be EPRI you'd be a co-author on a white paper that EPRI would publish, summarizing essentially the context of the results. And if it's interesting enough, it's something that could potentially turn into a larger project that takes off. But let me get back to the money real quick, Samantha. Right? We're going to be selecting 3 winners, the top 3. So first place, we're awarding $10,000 US. If you apply by yourself, all of that is coming to you. If you apply as a company or with a group, that goes to your company. If you apply, whatever, you split it how you want it to. But first place, $10,000. Second place, $7,500, and third place, $5,000.
Excellent. What a cool opportunity for students.
It is incredible. And I'll tell you, if I wasn't designing this challenge, definitely I'd get something in there for sure. This is an opportunity that I think nobody should pass up on. It's an incredible one, and you never know who is. I mean, you really don't want to look at whether this company is submitting or this institution is submitting. That holds no factor in the determination of the selection of these ideas. If it's disruptive, if it's innovative, if it's thought-provoking, that's what we're going for. That is what we're looking for in this challenge.
I really love your enthusiasm for the challenge, and I really appreciate all three of you joining me today to give us a little background on fusion and quantum computing, and then EPRI's 2025 Quantum Challenge Fusion Edition. So with that, I want to give you guys just one more chance to share any other thoughts or insights or with our listeners. So Diana, what do you have for our listeners?
Yeah, I mean, I'm truly excited for this challenge. You know, even with all the technical milestones and agreements being signed and announced in the fusion industry, there is still a long path towards commercialization. There's a lot of physics challenges, there's a lot of engineering challenges, a lot of material science challenges to get fusion to, a viable pilot plant and then eventually a full commercial power plant. And the more tools we have in our tool belt to address some of the most complex problems in the universe, I think the better and the faster we can get to developing fusion for our use.
I love it. I love how big you think, Diana. We're talking about universe. We're talking about universal forces. It's awesome. Charlyne, any final thoughts for our listeners?
I'd just say if you have a computer or a phone, submit an application. EPRI is doing a phenomenal job in placing itself as a technology leader in technology innovation in this area by doing something incredible that is crowdsourcing ideas and proposals, not even just specific to the US. This is a global challenge. So whether you're in South America, North America, in Australia, Iceland, wherever, it's a global challenge. Again, anybody can submit.
Well, it's a good thing this is a global podcast.
Yes,
so
absolutely. So between now, I think that the challenge has been open for about a little over a week now. So folks have until, I believe, April to submit an application. But let me tell you where to find it before we come off here and miss that information. If you Google EPRI Quantum Challenges, the first link that shows up, you want to click on that. And then you want to go to the part of the page that specifically says the 2025 Quantum Challenge Fusion Edition. Hit on that. That will take you to the landing page for the challenge. And then you can take it from there.
Great. And we will include that link in the episode description. So if you are interested, just look at the description for this episode and you will find all the information on where to go, what you need to apply and due dates and all the things. Again, thank you, ladies. I'm so glad you were able to join me today. And to our listeners, thanks for joining us once again, and we'll talk to you next time. Thanks.
If you like today's show, we invite you to subscribe to our podcast. And feel free to share the podcast with your colleagues and friends. For more information about EPRI, please visit our website at www.epri.com. And don't forget to follow us on LinkedIn and Twitter at EPRI News. Together, we are shaping the future of energy.